for motion, I'm starting recording. Yeah, I'm starting record. I have already started recording. So, first of all, we have to talk. When we have to talk about physics, the first lessons in the physics classroom in university, mostly it was asked the student to talk about what is about physics. However, mostly for the second lesson, we will talk about the physical quantities. So actually, in university, we use 1 hour to talk about this page, okay, unit. So physical quantities means that a feature that can be measured, okay. Every physical quantity would have a value and a unit. It's very important to state the unit whenever the quantity is written down. I remember that my teachers have said that, can everyone mute your mic? I see that perhaps some of you have a mute mic. Okay, so for most of the because if without the unit, only the value is meaningless. We don't know what is the physical quantity. Therefore, we have to write down the unit. You can see, even though some of the units they have no physical quantity, like radian. However, we still want you to write down the unit for it because it gives the meanings for the values. Okay, so and also when we have to use the equation and the formula provided in your formula sheet, or something that you have to remember that is not provided in the formula sheet, please use the SI unit. Okay, there are several primary units. We call it primary because at the very beginning of they structure this kind of system about science, about physics, they use these 7 physical quantity. Okay, at the very beginning, they use mass. 1 kg is actually a mass of 1 metal box. Okay, 1 metal bread. Okay，一個金屬鑽嘅重量嚟㗎咋。佢當其時就係定立一嚿嘢，嗰嚿嘢就係佢嘅質量就係1 kg 啦。Okay, length also 1 meter. They are still storing it with inside the museum. Okay, that 1 meter metal bar. Okay, time 1 second, and then the temperature we use Kelvin, okay, and the amount of substance we use molar. Okay, luminance intensity candela. Candela was which mean what? The light emitted from 1 candle. Okay, you can see this is a very not precise physical quantity. Actually, all the units they just use it to have a common ground to communicate. Okay, so actually, are they very precise? At the very beginning, they are not. So, however, for the following physical educations and also the research, we have designed some things to talk about this to be very precise. Like the second is 1 atom that vibrate how many times? Okay, the time it takes. Okay, and also kilograms. They have already used carbon. I have forgotten carbon what. So a number of carbon, and then it would weight 1 kg. Okay, still very good. Okay, so it's not that important. So, however, this kind of units can deduce other kind of units. That is very important because if you have forgotten the the actual units that you need to use, then you can use the formula to compose the new unit, the complex unit for it. Okay, like for F equals to ma, the unit of F, which is Newton, we know that. However, actually, we can use kilogram meter per second square to state the unit of Newton. And also for work, it would be F times the distance traveled. Okay, so Joule can be represented by Newton meter. Therefore, actually, if we use this use this to represent the force, actually, it is equals to joule per meter. Okay, they have the same physical meaning. Okay. Similarly, like this, the torque is actually the F cos D. So the unit of moment. Normally we use Newton meter. Actually, they have the same physical quantity with the energy joule. Okay, the unit of energy joule. Okay. Another thing that we have to remember is the prefix. Okay, you can see normal standard prefix. They are separated by 3. Okay, so first kilo. You have to remember kilo. That is your fan. Okay, you see it every day. Okay, if you study physics, you see it every day. Mini, also very important. 10 to the power negative 3. Mil, micro, 10 to the power negative 6. Okay, some they have suggested using other new symbols to represent the mil because mil is not a English character. Okay, but we are still sticking using this. Okay, so nano is also very common. Okay, the others they are not that common, but have a briefly understanding. And it's actually you just remember the order of this prefix is okay. So not standard, it would be D and C. 10 to the power negative 2 and 10 to the power negative 1. Okay. Remember, if you want to use the prefix like volume, it is XVM3. Okay, you can do the calculation to convert it into the SI unit. Then V is equals to X 10 to the power negative 2 beta square. Okay, so it will be X 10 times 10 to the power negative 4 meter square. Okay, you can convert it in back to SI unit using this kind of things. Okay, go. Okay, so for the quantities, actually we can divide it into 2 kinds of quantities. First one is scalar. The second one is vectors. Okay, actually, if you study physics in university, there is something called tensor. So we don't have to know about tensor. Okay, if you want to discuss about tensor, you can talk with me later on. Actually, I'm not that familiar with it. Okay, so mostly scalar and vectors is okay in DESE syllabus, even though in most of the university syllabus, scalar and vectors is okay. So scalar means the quantity will only have the magnitude, but without the direction. Okay, there are multi kind of example of scalar like time, mass, length, volume, and temperature. And for the vectors, the most important thing for vector is that they have the direction. You have to consider the direction. Okay, like commonly in our mechanics course is the displacement, the velocity, and the acceleration, and the force and the momentum. You can see actually, mostly if you have studied M1, M2, then you know that we use an arrow on the symbol of the physical quantities to represent its vectors. Okay, so vector. So actually for force, it's a scalar multiplied with a vector. So scalar without direction. So scalar times a vector, it would become a vector. Okay. Momentum also, because it is multiplied the mass and the velocity. Velocity is the vector. So m times vector, scalar times vector become a vector. Okay. So normally it can be represented by an arrow to indicate the direction and the length represent the magnitude. So actually, but actually most of the past paper does not count this kind of things into the marking. The length of the arrow actually represent the length, actually represent the magnitude of the vector. So if most of the time then a larger force use a longer arrow to represent it. Okay. So the vector, the magnitude of a vector must be a positive value. What does that mean? Because the sign of the vectors actually only representing the direction only, representing the direction only. Because let's see, normally for the vectors, negative 100 kilometer per hour is larger than negative 50 kilometer per hour. Okay, this is larger than it because we only concern about the magnitude only. If we talk about which is larger, okay. Another very good example is this: negative 20 meter per second is larger than 10 meter per second because the sign is only talking about the direction only. Okay, so physical quantity is not a scalar. Weight is a scalar because weight is a vector. However, mass is not. Okay, mass is a scalar. Mass is talking about how many quantity, how many molecules there, how many amount of substance is there. Okay, weight is a force. Okay, force is a vector. Voltage, charge, and work. Work is an energy. Energy is a scalar. Voltage is the energy, electrical potential energy per charge. Okay, both of them are scalar. Therefore, this is a scalar. Okay, measurement of the position. Okay, position. First of all, we talk about the scalar that can measure the position. Okay, so that would be the distance. Okay, distance is a scalar quantity. We can use meter to represent it. Okay, if we talk about the distance, we are talking about the total length of the actual go through. Okay, total length. Okay. And for the displacement, it's a vector quantity with both magnitude and direction. Also, because they are all talking about the change in position, so their units are the same for meter. Okay, and for the displacement, it's only concerning the starting and the final position only. So in this case, the displacement is this one. Okay, we don't concern everything in between. We only concerning the starting position and the final position. Okay, and the vectors, if we want to draw the vectors of the displacement, it's from the starting point to the final position. Okay, the arrow should be pointing from the starting position to the final position. Okay, because this is the vector, so we have to concern about the direction too. And for the displacement, that would be independent for the path because we ignore everything in between. So for the path A and B, they have the same displacement, even though they have the distance, a different distance traveled, but they have the same displacement. Okay, so of course, if it is moving along a straight line, then the displacement is equals to the distance traveled. Okay, so for movement, okay, movement, we can use the average speed to represent. Okay, so actually, the average speed is the distance traveled per unit of time taken. But mostly, I would like to ask you to write down this. Actually, this can be represented by other words like the rate of change of distance. Okay, actually, this is a very common represent. for this kind of thing. The rate of change of means that the change of, okay, let's see, the change of means delta B. The change then delta, okay, delta B. The rate of mean over time, the rate over the time taken. Okay, so you can see it here, okay, and because the distance is a scalar quantity, speed is a scalar quantity, so no direction. By the formula, we can deduce the unit of the speed is meter per second, okay? And also we can use kilometer per hour. Kilometer per hour, if we want to convert the unit back to meter per second, actually, we can do something like this. So 1 meter, 1 kilometer means that 1,000 meter. And then 1 hour. So 1 kilometer over 1 hour is 1 kilometer per hour. Okay, equals to 1 times 1,000 meter over 360 times 60 seconds. Okay, whenever we want to convert the unit, actually we can do something like this. Okay, a girl walks along a straight road from point A to point B with average speed 1 meter per second. She then returns from A to B along the same road with average speed 2 meter per second. The average speed of the girl, find the average speed for the girl, for the whole journey. Okay, so first it takes 10 seconds to go to there. Okay, for example, takes 10 seconds. So then the length would be 10 meters. If it is faster one time, then it would become the time taken would be 5 seconds. Okay, so if we calculate the total distance traveled would be 20, and the time taken would be 15. Okay, then we can calculate the answer like that. Okay, we cannot do something like this. We cannot just add them together and then divide it by 2. We have to consider back to the basic, okay, which is the average velocity. The average speed is the total distance traveled by time. Okay. 好啦，咁去 velocity 啊。So average velocity is the displacement per unit of time taken. Okay. So for the displacement per unit of time taken, so also you can say something like this. The velocity is actually the rate of change of okay, displacement. Okay, because the displacement is a vector quantity, therefore the velocity also a vector quantity with direction. Okay, so if it is moving on a and on a straight line without changing the direction, then average velocity is equals to the average speed. Okay, so not something important. So a man takes 30 seconds to walk 18 meters towards the east. Then he takes 10 seconds to return to 60 meters towards the south. Which of the following statement is all correct? The magnitude of the resultant displacement of the man is 140 meters. So he walks 80 meters to the east and then 60 meters to the north, to the south. Therefore, the displacement, we only concerning from the starting to the from the initial position to the final position. So if we calculate the S, it should be 12次加62次開放間100。Okay, this is 100 meter. So this is 1. Okay, the average speed of the man. So let's see. It takes 30 seconds to go. So the distance traveled is here. Okay, so for the average speed, it would be 80 plus 60 over 40. Okay, so it would be 3.5. So this is 1. The magnitude of the average velocity of the man is 2.5. Okay, then 100 over 40. Okay, 100 over 40. Because it is the displacement over the time, so it will be 2.5. Okay, a car starts at point A and travel along a circular path of radius of 30 meters. After 15 seconds, the car returns to point A. Find the average speed of the car within this period of time. Okay, so it takes 15 seconds to complete 1 circle. So the distance travel is 2 pi r, and the average speed is 2 pi r over 15 seconds. Okay, 2 pi r, 2 times pi, 2 times pi, 2 times pi times 30 meters over 15. Then it will be D. Okay, remember what it is asking you to calculate. It is asking you to calculate the average speed. If the question is asking you to calculate the average velocity, then because it's, if we consider the starting point and the ending point of the path, they are the same. Therefore, the displacement it travel is 0. Then the velocity is 0. Okay. So let's see. The figure above shows that 3 path 1, 2, 3 from X to Y on a horizontal plane. 3 students take the same time to travel from X to Y via the 3 path respectively. 即係佢哋各自用行一條路啦。Which of the following physical quantity about their journey is or are the same? So the displacement, because from starting to the end, they are the same. So displacement are the same. Distance, because their path is different. Therefore, they have different distance. And for the speed, you have to remember, this is very important. You have to remember that speed is the rate of change of distance. Okay, it's not the rate of change of displacement. So, because their distance is not the same, therefore, the average speed is not the same. Okay, so a toy car travel due east at 4 meters per second for 2 seconds. It then immediately turns north and travel at 2 meters per second for 3 seconds as shown. Which of the following statements is correct? Okay. Okay, the average speed. So we have to calculate the average speed. The average speed is the distance over the time. The total distance would be 40 meters. Over the time taken would be 5 seconds. So 14 over 5, it would be 2.8. So this is 1. Okay, so the total distance traveled is 40 meters. Yes. The resultant displacement is 10 meters. So let's do from the beginning to the end. Okay, so this is the displacement. Then 6. This is going on. This is 10. Okay, good. So the average velocity is the displacement per time. Okay, displacement per time. So 10 meters per 5 seconds. So 2 meters per second. Correct. The average velocity is less than the average speed. Correct. Okay. So after talking about the average speed and the average velocity, we have to talk about the instantaneous speed and the instantaneous velocity. For the instantaneous speed, it means that the speed of a body at that instant only. Okay. For the average speed, we have to consider the whole journey. However, for the instantaneous speed and the instantaneous velocity, we are always talking about that moment only. It can be changed next moment. So normally, we can use the speed meter to record the instantaneous speed. This have been appeared in the public exam. So they just give you a graph and then ask you is that what is what is its measuring? Okay. So the variation of the speed at different instants can be shown in the speed time graph lah. Okay. So this can show a car is moving from the west. It is accelerated. Okay. The speed is increasing. You can see from t equals to 1, the speed is 20. And then from t equals to 2, the speed is 40 kilometer per hour. Okay, similarly to the instantaneous speed, the instantaneous velocity is the velocity at that instant only. They would have the same magnitude because for that instant, they must have the same magnitude. However, for the instantaneous velocity, we have to consider the direction as well. Okay. So in this example, you can see that car A and car B, they have the same speed and the same magnitude of velocity, but because of their direction is different, so they have different velocity. Similarly, when you face the circular motion, okay, you can see even though they have the same speed, circular motion, even though they have the same speed, however, because of the direction of the velocity have been changing, therefore, there are change in velocity. Okay, so for the variation of the velocity also can be shown in a velocity time graph. Okay, then we have to discuss something called uniform motion. Okay, uniform motion and uniform accelerated motion are very important concepts in mechanics. Okay, first one, uniform motion. It means that it is moving with a uniform velocity. Uniform velocity, okay? It's not talking about uniform speed, it is uniform velocity. Okay, therefore, circular motion is not a uniform motion. Okay, uniform circular motion is not a uniform motion. Okay, all right. So it is not uniform when there is change in the speed or the change in direction. If we want to calculate the relationship in the uniform motion, we can use the displacement equals to the Vt or the distance equals to the Vt. Okay, and also for the projectile motion, their horizontal direction is a uniform motion. The horizontal direction of projectile motion is a uniform motion. Okay, so if because it is moving with a uniform velocity, which means that the velocity does not change throughout the whole journey. Therefore, the average velocity is also equals to the v, to the instantaneous velocity. Okay, they are the same. Okay 啦，好啦。So for this uniform motion, because the direction is not changing, therefore the path should be equals to the displacement. So the velocity would be the same as the speed. Okay. For most of the graphical representation of uniform motion, okay. So you can see normally, not normally. So displacement time graph would be a straight line, and then our velocity time graph would be a flat line. Okay. So a car is traveling at 50 kilometers per hour. How much time it takes to travel 500 meters? Okay. So we just do the calculation. So S equals to Vt. Then, because if we want to use the calculation of by using the formula, we have to convert it back to the SI unit. So the V, we have to convert it by multiply 1000 and then divide it by 3600 to convert it back to meter per second. Okay, then we can calculate the time. After talking about the velocity and the speed and the displacement, then if the speed or the velocity is changing, then we have to measure the change of the velocity, right? Therefore, something new has been defined. Acceleration is the rate of change of velocity. So, in this time, starting from here, you have to remember what is the difference between the V and U in the equation. The U, which means that the initial velocity, and V means that the final velocity. Okay, the change in the velocity divided by the time taken would be the acceleration. Okay, and the acceleration 5 meters means that for each second, the velocity is increasing 5 meters per second. Okay, and also like the velocity, because the velocity is a vector divided by time, it is still a vector. Therefore, acceleration is a vector. 好啦， if the velocity and the acceleration is the same direction, then it is accelerating. The speed will be increasing. However, if the velocity and the acceleration are opposite of direction, so it would decelerating or returning. Okay, changing the direction. Okay, oppositely. Okay, so another point, if it is having an angle with the velocity, then it will change the direction of the velocity. So there are no acceleration in two cases. These two cases is very important when we have to do about the force analysis. Okay, these two cases, the body does not have acceleration. First, it is at rest, always at rest. Instantaneous at rest does not mean it is no acceleration. It is always at rest at a long period of time, which means that there are no acceleration. Okay, always is important 啊。你唔好同我講話佢 instantaneous at rest 喎，咁咪即係佢冇力咯。Instantaneous at rest is not 㗎嚇，佢 always at rest 先係啊。好啦，另一件事 ，the second point is if it is moving with a uniform velocity, which means that no change in direction. Okay, velocity means include direction. So uniform velocity without changing the direction. Okay, so note that a body may have no velocity but possessing acceleration. Okay, or it is static or momentarily at rest. Okay. 好啦 ，equation of motion under constant acceleration 啦，咁佢就會有4條式啦，呢4條式都有噶啦。OK， 好啦 ，you only need 3 of them to choose which equation to be used. OK， 好啦 ，like if I have the initial velocity and the final velocity and the time, I want to find out the A. Then I see which equation it satisfies for me to use. Okay, then it would be this one. Okay, to find out the acceleration. Okay, actually using this 4 equations, you can forget about everything I have teach about the calculation of the instantaneous speed because this 4 is already included the above definition. Okay, and also for the uniform motion actually means that the acceleration is 0. So you can see this one is actually the same as before. If I just erase what at the back, okay, about the acceleration, okay? Hold on. So if we want to use the uniform acceleration formula, there are some conditions, okay? First one, it has to be moving along a straight line, okay? The second one is the acceleration must be a constant uniform accelerator. And you can say that you don't have to concern about it because we are only dealing with constant acceleration during your DSC syllabus, okay? For changing acceleration, it was changing rapidly like this acceleration time graph, but not continuous changing acceleration. Then you just divide it into two parts to do the calculation. It's okay. A racing car accelerating from west to a speed of in 3.2 seconds. Find the average acceleration of the car. By using the V equals to U plus AT, then we can calculate the acceleration. Okay? So John is riding a bicycle along a straight road with a uniform speed of 10 meters per second. At the time t equals to 0, it sees a warning signal. All right, John applies the brake for 2 seconds to bring the bicycle to rest. Rest means that the velocity is 0, okay? It's also very important for you to understand what is the meaning of the English word back to the physical meaning, okay? So at rest means the V is equal to 0. Okay, so find the distance traveled by the bicycle when it is decelerating. So the original velocity is this one. This is U. V is equal to 0. The time is this one. We got 3 things and find out the distance. So we use this formula. Okay. I think start from west. West means that U is equal to 0. Beginning. Okay. So acceleration equals to 2 meters per second square. And the minimum takeoff speed is 60 meters per second. Find the minimum distance traveled by the plane before its takeoff. So, which means that this is the V. We want to find out the S. Okay, we got U, A, V, S. Then we use V square equals to U square plus A, S. Okay, we find out that which physical quantity we want to find out. And then which other 3 physical quantity we have. Then we choose which formula should we use. Okay, I'm not going to deal with this formula because this whole formula you can access it through the formula sheet. But the most important thing is you have to find out the information from it, from the questions. So a car undergoes a uniform deceleration during a straight road. The velocity decreased from 30 meters to 20 meters per second after traveling a distance of 100 meters. How much further will the car travel before it comes to a rest? Which means that, okay, there are 3 velocities. So how do we calculate it? Then you have to divide it into 2 parts. First is it travel 100 meters to decelerate from 30 meters to 20 meters. Okay. So in this process, we can find out the acceleration, right? Because we have the U and the V and the AC. We can find out the acceleration. And because it is using the same acceleration, then we can find out by putting it into another form. It is the V is 0 and the U becomes the 20 meters per second equals to plus 2 times the acceleration. Then we can find out the distance is 80 meters. 好啦 a body is moving along a straight line with uniform acceleration a. It takes 2 seconds to reach a velocity of 50 meters per second, and then another 3 meters to reach the velocity of 22.5 meters per second. So the initial velocity u, find the initial velocity u and the acceleration a. Then this is a very more complex questions. Okay, it takes 2 seconds to reach the final velocity, which is 50 meters per second. Then we have to apply the formula 2 times. Okay, then we will have 2 unknown and 2 equations. Then we can solve it out. Okay, so a body is moving along a straight line with a uniform acceleration a. It takes 5 seconds to travel a distance of 60 meters, and then other 5 seconds to travel the next 155 meters. Find the initial velocity and the acceleration a. Again, you have to build up 2 equations to find out the 2 unknown. Okay. So graphical methods, that is the most difficult part and for the student to understand, because plotting the graph is difficult. So the displacement time graph, which is showing the variation of a displacement from a certain point. Okay. So actually how it can be plotted. Okay, so let's see. So let's see this one. If I change the center of the wheel, okay, I check the motion of it. Okay, so let's see. I just plot every point for the same time interval to take a photo of the center of the wheel, just like this. Okay, I just take photo and then put them together on the different layer of the photograph. Okay, so then I can plot. You can see the displacement of the wheel is increasing. Okay, by using the data, we can calculate the velocity time graph too. And you can see the y-axis. Here are not significant change in the y-axis. Okay, which is normal. Okay, let's see one more. Okay, this is a project. Okay, so again, for we to basketball. Okay, then we can plot out if we just take the photo. For the displacement time graph, it's just like we just take the photo. Okay, so we can see the x is like this. Okay, so it is increasing. This is going away 嘛嗱，你可以當咧，你將幅圖順時針轉一次咧，咁就係每一下佢行遠咗幾多，佢嘅 time interval 每過咗1秒之後，佢就行遠咗幾多，你就點一點落去。This is the way of plotting a displacement time graph 啦。Okay, for the y-axis, you can see it like this way. Okay, so the slope of the graph is actually equals to the velocity, because the slope of the graph, if you have learned MQR, okay, so the slope of the graph would be this one, delta s equals to delta t. Okay, so by the definition, it would be the v. Okay, so if it is a straight line, then it would have a constant slope. Constant slope mean that a uniform velocity. Okay, for this horizontal line, in the displacement time graph represent that the body is at rest, because there are no changing of the displacement. Okay, you can see in the BC section, the displacement does not change. It means that the distance from the original position are not changing. So you can see in BC, the object is not moving. Okay? 好啦 then for section A 咧 to B, it is moving forward. Okay? And for the section D and E, it's just moving to the another side. Okay? Moving backward. And it has been passing through the A original position. It would return to the original position at time E at D. Okay? So the area under the curve has no physical meaning. Okay? So the curve indicates the change of the speed. Therefore, if this is a curve, this is not the change in the speed. So there would be an acceleration or deceleration. Okay? So you can see if the slope is increasing, 變得越嚟越斜嘅話咧 it would be accelerating. Okay? Because the speed is the instantaneous speed at different point is different because the slope is the speed, slope is the velocity. Okay? For the graph at the right hand side, you can see even though the displacement is increasing, but the slope is decreasing, so that it is deceleration. The velocity is decreasing. Okay? So if this is moving with a straight line without turning back, then the displacement time graph would be the same as the distance time graph. Okay? So let's say the displacement time graph of an object moving along a straight line is shown below. So which of the following graphs represent the relationship between the velocity time and the time of the object? Okay, so first one, this is, we have to talk about the slope. This is a large slope, so this is a constant velocity. So it's either this or this. Okay, then you see the another part. Because this is a flat line in the displacement time graph, which means that the velocity is 0. Okay, both are okay. So the last part, we see that it is a constant velocity. However, the slope of the displacement time graph is smaller than the first part. Therefore, the answer would be D, because the velocity is smaller than the first part. Okay? And also, if we want to talk about the motion graph, you have to know how to describe the motion. Because it's very common as the good old days, okay? However, for recent years, it has been asked like 3 or 5 years once, okay? So, but you are still required to know how to describe the motion, okay? You have to distinguish which part that you have to divide it for, okay? Like, for example, for this one, you have to divide it into B part. The first part, you can see that the displacement is not changing, so which means that it is at rest at the first part. And then you can see from t equals to 10 seconds to t equals to 20 seconds, it is accelerating. This is a curve. And then for the last part, it is moving with a constant velocity or uniform velocity would be accepted. Okay, so you have to state the time interval too. First, you state the time interval, and then you state what is the motion. You describe the motion. Okay. Well, FH velocity, I don't ask you to calculate this one. Okay. So, a car travels along a straight road. The variation of a distance of the car from a fixed point x on the road with the time shown above. So which of the following statement is correct? So the speed of the car is decreasing. Okay, the distance time graph is only talking about the distance only. So we can see that the slope of this graph is a constant. Therefore, the acceleration is zero. So the speed is not changing. Okay. So the car is moving towards to P. Okay. You can see the variation of the distance of a car from fixed point P is the distance. Okay. So this one distance equals to zero is P. So at last, the distance is zero. So which means that the distance between the car and P is zero. Then it is moving towards to P. Okay. So this is an unbalanced force acting on the car because the acceleration is zero. Therefore, no unbalanced force. The area under the graph denotes the total distance traveled by the car. Okay. That is not correct. The distance time graph, the area of distance time graph have no physical meaning. Okay. So let's see. The figure above shows the distance time graph of two toy cars P and Q moving along the linear track. Which of the following statements are correct? So they would meet. A car would reach the 20-meter mark first. Yes 咯 ，P 係呢個啊嘛，所以佢咪掂到先咯。好啦 ，OK，car P is overtaking。overtaking 係咩意思咧？超過咗佢啊，爬咗佢頭。At t equals to 5，係啊，佢去到呢度嘅時候，好啦，係咪佢個 distance 係大過 Q 嗰個 distance？可以，咪就係啱咯。OK， 好啦 ，the average speed of car in the first 5 seconds is smaller than that of car Q。嗱呢度你就要睇啦，咁佢就講話啦 ，average speed，average 嘅話 ，you have to consider the total distance travelled per time。OK，total distance travelled per time。Therefore, for t equals to 5, their distance would be the same. Their distance is the same, and the time taken is the same. Therefore, they have the same average speed. So, answer is A. So a car travels along a straight road from A to B with a uniform acceleration. The speed of the car is v1 at the instant when half of the journey time from A and B is good, and the speed is v2 at the midway of A and B. Which of the following is correct? 好啦，講話啦，佢咧就一路加速緊，咁咧佢就嗱呢條心㗎，呢條心，好啦，佢係一路加速緊，咁咧佢用一半嘅時間嘅時候，佢個速率咧 speed 咧係 v1，咁然後咧佢喺行到一半嘅時候，即係個 distance 係 half 嘅時候咧，佢嗰個係 v2。咁問你兩個嘅關係係乜嘢？咁好啦，因為佢係越行越快嘅關係，佢去到尾段嘅時候咧，佢行嘅距離係會遠啲嘅。咁所以咧，我哋 plot 到個 graph 係咁嘅樣啦。所以我哋知道原來 V1 咧係會細過 V2 嘅。好啦，呢個真係你需要畫圖去畫出嚟，如果唔係好難做呢條。好啦 ，after discussing the displacement time graph, we have to talk about the velocity time graph. So velocity time graph, which means that plotting the variations of the velocity over the time. Okay, the slope of the velocity time graph, which would be the acceleration. Okay, the slope of the graph 咧會係 acceleration 嚟嘅 ，because if we talk about the slope is delta v over delta t equals to acceleration by definition. Okay, the rate of change of velocity is the direction. Okay, for the area under the graph would be the displacement. Okay. OK， 好啦 ，Vt is equals to the displacement 啦。So the motion of the body along a straight line. There are few different kind of things. Few normal, few common. Okay, so for this one, if it is moving with a uniform acceleration, you can see the velocity is increasing at the same rate. You can see here, okay? Like this is time equals to 1 and 2. Then this is delta V. For the same time, in this part is delta V2. Okay, they have the same change in velocity. Okay, at the same time interval. Okay, so for constant velocity, so then acceleration is equal to 0 lah. The slope is equal to 0 lah. Okay, uniform deceleration, the slope would be equal to the acceleration. However, the slope is negative. Okay, positive and negative are very important because you have to consider the direction because this is a vector. Okay, 咁好啦。Then you can see this part. First, it is uniform accelerator and then decelerator. And then at some point, this is the extreme point and change the direction because the velocity has meet 0 and this is momentarily at rest. Okay, momentarily at rest, 瞬間靜止. Whenever it needs to change the direction, it have to reach the point of momentarily at rest first. Okay, and then it will start to accelerate. Okay, you have to know that below the point of 0, it's just moving backward, moving into another direction. Okay, but the magnitude is increasing. Okay, the magnitude of the velocity is increasing. Therefore, this is actually accelerated. Okay, at some point it goes back to decelerate. Okay, the acceleration is positive because the slope is positive, but the velocity is still negative. Therefore, it is backward deceleration. OK， 呢邊度咧向呢邊佢就越行就越慢啦。好啦，咁佢個 area under the curve 就係個 displacement 啦。OK， 好啦，佢如果係喺條線上，係喺0嗰條線上面咧，佢就係 positive 嘅 displacement。Under the straight line of 0咧 ，then it would be a negative displacement. Negative displacement is only meaning it's going backward. Like for this one, it's going to north, and this one is going to south. OK， 好啦，我仲有幾多？都唔係好多嘅。OK， 好，講埋佢啦。今晚爆埋個 motion 佢啦。好。好啦，嗱 ，the figure shows the velocity time graph of a car traveling along a straight wall。我錄咗啊，你哋遲啲你話真係太攰，你而家休息下，然後你遲啲睇翻錄影都得。OK，so the figure shows the velocity time graph of a car traveling along a straight wall. Which of the statement are correct？ 好啦，咁佢就話啦 ，the car changes direction of travel as t equals to t1。我哋睇啦。佢呢一個係一個 velocity time graph. Therefore, at this point, the v is equal to 0. And also, originally, it is moving this way, positive, and then it become moving to the opposite side. So this is correct. So the car is fastest when the start from the starting point at t equals to t1. OK, farthest way away 最遠啊，好遠啊，最遠。好啦 ，so you can see that in this point, the S1, this is the area under the curve, is the displacement traveled. It would be like this one. And then for the second part, this part is actually moving backward. Therefore, for the whole journey, this is the longest distance from the original point. And its return to its starting point at t equals to t2 is not because this area is smaller than the first part. So it's only going backward a little bit, haven't returned to the original position. So 1 and 2 only. 好啦 car A and B 咧 travel along the same straight road the velocity time graph of two cars is shown above. Which of the following statements about the motion of two cars at t log is always correct? So two cars can meet each other at t log. Now, actually, this kind of questions that are very confusing because you normally mix it up with the displacement time graph. The main point of reading this kind of question is first you have to know which kind of graph you are watching. Okay, this is a velocity time graph. So when we have to talk about whether they met each other, we are talking about the displacement they have traveled. So for this one is the area under the curve. Okay, you can see these two parts is different. So they didn't meet each other at that point. So two cars are moving with the same speed but opposite direction. Okay, this is not correct. You can see they have the same magnitude and they are same positive. Okay, therefore they have the same direction. They have the same direction and the same magnitude. So car A is accelerating and B is decelerating. If we want to find out the acceleration, we need to see the slope. For A, the slope is positive. For B, the slope is negative. Therefore, A is accelerating and B is decelerating. Okay, so B. Alright, example. The diagram shows the variation of velocity of an object with time. What is the distance traveled by the object in the first 3 seconds? Okay, first, this part is positive. So let's say it is moving to the right. Then calculate it. The area under the curve would be 20 times 2 over 2. Okay, area of triangle. Okay, so it would be 20 meters. And backward 5 meters. Okay, so the distance traveled by the object, the distance 我問你係 distance So distance means the total path that it has been traveled. So it would be 20 plus 5, 25 meters. OK， 嗱呢條音嚟嘅，呢條咧音嚟咩咧？音嚟咧傻豬豬咧以為佢實係計 displacement。OK，but actually this question asks you to calculate the distance。OK，just be careful。好啦 ，two cars A and B start from west simultaneously and travel along the same straight road. The velocity time graph of two cars are shown below. Which of the following statements about the motion of two cars is correct? They have the same average velocity during the time interval of t to 0 to t Okay, so average velocity, which means that the total displacement over time. So if we want to talk about the total displacement, then for A, the total displacement is this. For B, displacement is this. If they have used the same time, then the displacement is different. Therefore, they have different average velocity. Okay, they would have the same acceleration during time interval from 0 and t. Okay, if we want to talk about average acceleration, then we only concerning the initial velocity and the final velocity. They are the same. Therefore, they have the same average acceleration. Okay, they travel the same displacement. We have discussed it at the first corner. Okay, so this is not correct. So this is B. Well, so at t equals to 0, a car and a trunk at the same point on the horizontal straight wall. Their velocity time graph is shown in the figure. Which of the following is correct？ 好啦，咁佢哋兩個咧，個 trunk 咧就係咁嘅，跟住個 car 咧就係咁嘅樣嘅。Okay, as t goes to 10 seconds, the car is 100 meters behind the truck. Okay, so which means that we have to find out the displacement they have. Okay, for the truck, it is 10 times 10 over 2, so it is 50 meters for the truck, for the car. So, and for the trunk, it would be 100 meters. So this is not correct. So as t equals to 10 seconds, the car catch up the trunk. So which means what? They have the same displacement. If they have the same displacement or not, okay, at t equals to 10, no, they don't have the same displacement. Okay, so at t equals to 20 meters, the car is behind the trunk. So they have the same displacement. Therefore, D. Okay. So two particles P and Q start from the same position and travel along the same straight line. The figure shows that the velocity time graph of P and Q. Which of the following descriptions about their motion is correct? At t equals to 1, the P is changing the direction. Okay, this is not correct. So you can see it is the maximum of V has -2. So it is still moving downward. It is still moving downward. Okay, at t equals to P, but it is accelerating upward. But this is not changing the direction yet. It changed the direction when t equals to 2. Okay, so for t equals to 2, the separation between P and Q is 4 cm. So let's see. The displacement traveled by P is 2 times -2, which would be over 2, which would be 2 meters. Okay. And for Q, the area under the curve would be 2 meters. So their separation would be 4 meters. Because one is moving upward and one is moving downward when they are t equals to 0, t equals to 2. Okay, and at t equals to 4 seconds, they meet each other. So which means that they have to have the displacement under the curve. Okay, however, you can see for the Q, the displacement under the curve is this part. Okay, for P, the displacement under the curve is this part minus this part. They cannot be the same. Okay, so the answer is B. So two cars A and B travel along the same straight wall. Their velocity time graph are shown in the figure. At t equals to 0, the two cars are at the same position. Which of the following statement is correct? 好啦，嗱呢嚿嘢比較麻煩啲啊，比較長啲，睇睇先。好 ，the car move forwards and then backwards. Did it change the velocity? The direction of velocity? No. Therefore, this is wrong. Okay. If it is moving forward and then backwards, it has to change the direction of the velocity first. Okay. It is only changing the magnitude only. Okay. This question is still want to check you whether it is a displacement time graph. Okay. So for t equals to t1, car leads car B, car A leads car B, which means that car A is in front of car B. So you can see if they are following on the same road and beginning they are in the same position. Now, first one you have to see whether they are beginning at the same point. If they are not beginning at the same point, then this is not correct. This may not be correct. Okay, so the area of A is larger than the area of B, so this is correct. So t equals to t2, the separation of the car is the minimum. Okay, so you can see they are only having the same magnitude of velocity. However, you can see for A, there are still a lot of displacement larger than B. Okay, hold up. For 4, T equals to T3, A is lag behind car B. No, because the area of A is still larger than B. Okay. 好啦 acceleration time graph 啦，嚟了啦 acceleration time graph 咧 so if we want to plot the acceleration changing along the time, so the area under the curve is the change of velocity. Okay. Hold on. If it is a positive value, if it is at the same direction for the velocity, then it is uniform accelerating. If the velocity is negative, then it would be decelerating. Okay, for it is the acceleration is 0, it must be at rest or uniform velocity. For the last one, if the acceleration is negative, then if the velocity is the same direction as the acceleration, then it is forward decelerate. So if they are same direction, then it would be accelerating. If they are opposite in direction, then it would be decelerating. Okay, so for this one, the velocity time graph of a car traveling along a straight horizontal wall is shown above. Which of the following graph shows the variation of the acceleration A of the car with the time t? So let's see it part by part. First one, it is accelerating with a constant acceleration. That means that it is neither A, B, or C. Okay, and then for t equals to 10 to 30, the velocity is not changing. Okay, the velocity is not changing. Therefore, it is 0. Okay, so it's still either A, B, or C. Okay, for t equals to 30 to 35, it is decelerating. It is slowing down. It is slowing down. So which means that this is negative. So it is neither C or B. And for the time interval of 35 to 40, it is backward accelerating. Backward accelerating. You can see this part. Actually, V is negative but increasing. Okay, negative but increasing. So the answer is B. Okay. So straight line graph. Okay, you can use mx per c to calculate the slope. Okay. So actually, we can use this to calculate, to put it into the formula, the uniform accelerated formula. So if the u is 0, just back for our calculation. So the vt graph would be v equals to at, then the slope would be a. Okay. If the graph is s equals to 1 over 2a squared, then the slope would be 1 over 2a. So actually, this v graph is quite common in past paper. Okay, v squared equals to 2as. Therefore, if we plot the v squared against the displacement, the slope would be 2a. Okay. So in 2007, this is one of the past paper. So the above graph shows the variation of the square of velocity v squared with the displacement s of a particle moving along a straight line. What is the acceleration of the particle? So this one, the slope, if you don't have to remember the relationship, you just need to use the original one to calculate it. So by v squared equals to u squared plus as, then v squared equals to 2a times s plus u squared. So we just import it into the y equals to mx plus c, then calculate the slope. Okay, calculate the slope, then the slope would be delta y over delta x. Delta y, it would be equals to 1, and the delta x 咁奇怪嘅 delta x 係 1 嘅 ，OK， 等於 delta x 係啦1啦，咁所以咧個 slope，therefore the slope is equals to the 1，OK， the m is equals to 1, which is equals to 2a，OK， then a is equals to 1 over 2a，OK， be careful with that。好啦，嗱 typical 嘅vehicles 啦。First, it has to accelerate first. It has to be accelerate first. And then it would be moving with a constant velocity. And then before it stops, it has to decelerate first. It cannot stop suddenly, okay? So you can see the motion graph would be like this. All right, again, you have to remember how to describe the motion. First, state the time interval first. And then, first one, you can see this is a velocity time graph. So, for the slope, it's a constant. Therefore, this is accelerated uniformly. Okay? So, and for the second part, it is, you can see the velocity is not changing. So, uniform velocity. Remember those words. Uniform velocity, uniform acceleration. Okay, then this part is decelerated uniformly. However, for this point, actually, you can state this point. Actually, I believe that stating this point is quite important. Okay, so if I'm the marker, I would love to state this point. Like when t goes to 250, the boat are momentarily at rest, okay? So, and then change the direction. So you can see it is changing the direction. So it is moving backwards and accelerating. You can see the magnitude of the velocity is actually increasing, okay? It's just changed the direction, but the magnitude of the velocity is changing, is increasing, okay? 好啦。So find the acceleration of the first 50 seconds. So calculate the slope of the graph. Not that important. So draw the acceleration time graph. Okay, you have to divide it into 3 parts. The first part, do the calculation, find out the acceleration. Okay, and the second part is 0. And the third part, again, calculate the slope by this one. Okay. 好啦，唔講呢條啦。Okay, so when you have to break the vehicle, you have some short period of time, which called the reaction time, which normally is 0.2 lah. It depends on how they state it in the questions. Okay, so because for the human, when we see there is an accident, we have to react and then push the brake of the vehicle. So there is a time interval. In that time interval, the car is still moving, okay, without our control. So the acceleration is 0. And then we start to brake, okay. The acceleration is opposite to our initial velocity, okay. So normally, the motion graph would be like this, okay. You can see it in 2005. I have remember is 2005, okay. But nowadays the concept of reaction time is not that important anymore. They haven't state that you need to know this, okay. So I just skip this part. 我哋 intensive 啦 ，OK，叭叭叭叭叭叭 ，OK，last part gravity。Okay, for Aristotle, they have used that. They think that the heavier ball would fall faster than a lighter ball. However, Galileo, he do an experiment. Okay, in the 16th century, he drops two balls with different mass on the top of that. Okay, so he found out that they have reached the ground at the same time. So, 我都沙 咧，after we have learned 我講慢少少呢部分，因為真係好重要。OK，雖然咧 Aristotle 咧，佢成日講啲嘢咧都係廢嘅，即係我哋都係 prove 咗佢係錯嘅。咁但係我覺得呢一樣係 this is very important that we prove the old man is wrong. OK, because one day the physical concept you learn would be captured. OK, one day. 好啦 always try accuse they are wrong, then you will get improvement. This is how human society to be evolving. OK， 好啦，感嘆完啲講啲感性嘅嘢啦。咁但係 Aristotle still a very important person and very respectful person because they start philosophy. Then we can learn this thing. OK。Try to think about the existence and everything and the phenomena. OK， 好啦，講完啲好似廢廢地，但係其實我覺得係成個科入面最緊要嘅嘢啦。好啦 ，the correct statement should be they should fall as the same rate if the air resistance is negligible. So they are both accelerating due to the gravity. Okay? This one is 9.81. Okay, if we talk about the gravity, we will talk about how it's come out. However, you can say that they are experimental value. Okay, so the acceleration due to gravity, which is independent to the mass, and the direction of the acceleration due to gravity is always vertically downwards toward the Earth. So, actually, for this, we are still using the uniform accelerated equation, just replacing the A to G, okay? And for something is released from mass, then the then the initial velocity is 0. blah 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 calculation 嘅唔同你高估啦。好啦，呢、個位咁佢就講話啦。He wants to check the reaction time. Okay, so after he have released, at that instant, he grab it again. Okay, so the distance for the ruler to fall, you can use this to calculate the time of the reaction time. Okay， 因為佢跌落嚟嗰個時間，你又即刻捉住佢，中間嗰個 time interval is exactly your reaction time. Okay, you can calculate it. So if using a heavier ruler is used, how would the result would be affected? Should not be affected because the acceleration due to gravity. You can see in this whole equation, there are no mass. So you can say they are independent. Independent, which means that they have no relationship. Okay. So Susan marks that the other side of the ruler so that the reaction time can be read directly. Okay. Explain whether the scale of reaction is correct or not. Now, this is not correct because the reaction time is proportional. The distance traveled by the ruler is proportional to the t square. Okay. However, here you can see he tried to make it everything is directly proportional. Then it is not correct. Okay. 好啦，硬幣與羽毛嘅實驗啦 ，so it's just use it inside the vacuum, then they find out that they have the same acceleration due to gravity lah. Okay, so this is the last column. So when it is floating upward, it is originally moving upward with our initial velocity. So in the whole process, acceleration due to gravity is pointing downward. Therefore, for the first part, it is decelerating. And then when it's met the maximum height, it is momentarily at rest. Now this is very important because for this part, even though it is momentarily at rest, the acceleration is still pointing downward. And for the last part, it is acceleration downward. Okay. This field graph is also important. Okay. So for the graph, you can see displacement time graph we have plotted in using the video physics lah. So one point, you can see this point the slope is 0. Okay. Then you can say it is momentarily at rest. Again, same thing. 好啦，呢堆嘢咧，而家好少考啊，唔講。OK， 自己得閒睇啦。即係 motion sensor 嗰啲，不過 motion sensor 我都要嘅，即係 motion sensor data locking 呢一度咧，都要望一望佢點做嘅 ，especially for experiment type 嘅 questions。OK， 好，咁我就停錄影啦。